कल पे इसका आंसर एक्सपोज देगा तब ये प्रॉब्लम है ना हमारा कंप्यूटर डिपार्टमेंट
सामने का अरे बाप रे इंट्रोड्यूस एक मिनट थांबा let me oh have we already started the slide press how do I get the symbols here all the menus where's the start slideshow thing in this
एक मिनट आप कॉल चालू कर ममता Yeah, we can share the screen.
नहीं मी गुगल ह्याच्यामध्ये ते स्टार्ट स्लाइड शो करणार होतो this browser is in some mode I think
I think it's already on slideshow.
is it no
Because you don't see the rest of the thing. कुछ और हो गया इधर
oh this one is updating now
What is updating? हो गया ना?
yeah
Good morning, one and all present here. KRVIA extends a very warm welcome to Dr. KRVIA. He's an architect from Bombay. He completed his PhD in architecture from University of California, Berkeley in 2018 and a postdoctoral research fellowship at the Technion Haifa, Israel in 2022. His research is concerned with the role of computing in architectural representation and architectural design more generally. His recent work has been concerned with developing models of how people use buildings and in considering how large image corpuses of the cities could be used as architectural representation. I now hand over the mic to Dr. Karthik.
hello good morning this feels like a little bit like a concert that you're surrounded so my name is Karthik I have to put this doctor in front of my name, which is very, very annoying, but I've been advised that it's a good idea to do that. So at the outset, this is a pretty deadly talk, because in a classroom, I know who you are. I have given you a syllabus. I know where we start at the beginning of each lecture, and I know where we end. But here I don't. I mean, you guys are what? First year? Are there any first years here? And then there's fifth years? There's fifth years here. So, and everybody in between, I presume? Yeah, some of them in between. So that's one reason why this is a deadly talk. The second reason it's a deadly talk is because, I used to be you a long time ago. But not only did I used to be you, I used to be you in the bad old-fashioned other place, JJ. in town. So when I was in JJ, you guys were like the cool happening, like new people around. So the cutting edge. I think that's still true, but the fourth reason is that my classroom was all drawing boards, and your classroom is now just flat tables. And that's a big change that's happened in the last 15, 20 years in the profession. So I've been asked to talk to you about research and about what research I do. Research is a sort of a sideline in architecture, but there are people who do it full time also. And there's a distinction between sort of architecture as a discipline, which is concerned with the built environment and concerned with it more broadly, and with the profession, which is concerned with practice, with clients, and so on. So these are distinctions, and some people say that the profession is a subset of the discipline, but it's really not. It's, I mean, the discipline is tends to become multidisciplinary very, very fast. So if you want to do research on architecture, you have to then sort of start learning other things. Like, if you want to do energy related work, you have to start learning like physics and engineering and all that. And if you want to do social science related work, then you have to start learning anthropology and sociology and economics and all those things. So yeah, we'll see how it goes. So okay. So I've called this thing problems in architectural representation. And architectural representation has basically gone through a fairly basic change because now we use computers to represent architecture. And by that, I don't mean that we use it to represent just spaces, but to represent problems. What problems do we solve? How do we define our problems? How can we define our problems? To what extent can we define our problems? And if you're first year, all this stuff is probably really bothering you because you just came out of school. And if you're fifth year, you're probably very tired of all this stuff bothering you already. So I've tried to organize this in like these sort of 3 bits. We'll get to number 4 if we can, but I'll just introduce it. It's some ongoing work that I'm doing. So when I was doing my undergraduate work, I took a break for a year and I worked with Sabu Francis. How many of you have heard of him? You're not a student, are you? So he's old now. He's retired more or less. But he studied architecture at IIT Kharagpur and he built this software on the side while doing his practice. It's basically an object-based modeling system. It's still around, but it was sort of one of the early BIM systems, which still didn't use the official BIM standard, other ISO BIM standard, but it was still a beautiful, elegant system. And that got me interested in sort of how you describe what abstractions you use to describe buildings and what kinds of abstractions you can represent in a computer. Now, this becomes a little bit of a vexed thing because theoretically you can describe anything on a computer. It's a universal machine. You can basically describe any problem and answer any question if you are able to formalize it. So it is a machine which can describe any machine. That's what the computer is. But it has a history. Computing appeared in sort of the 40s and the 50s. Got a great fillip because of the Second World War. This is one of the sad tragedies of the world that a lot of extraordinary technical advancement comes because of war. And at that time in the 50s, there was a lot of early enthusiasm about Turing's proposition that computers are machines that can think, and a lot of people developed it, and they sort of demonstrated this to a large extent, to the extent that computers could solve theorems, prove theorems and things like that, and that sort of got them to this place where people started like Alan Newell and Herbert Simon, for example. They started arguing that computers are machines which can think, and we won't really need theory anymore. And you will have heard echoes of this in another more recent argument relating to big data 10 years ago, where people start arguing, well, now we have all this huge amounts of data, but we won't need to do modeling and abstraction anymore. We won't need to do any sort of, we won't need to make as many assumptions as we could. We just work on the data. And both of those sort of optimistic positions proved to be false. I mean, it broke down really quickly, but and it broke down also very fruitfully, because what you learned is that computers are problems are underdetermined in most cases. Do you have a sense of what an underdetermined problem is? Okay. So you all know like algebra, right? So if you have two equations in x and y, okay, then if you have two equations, you can solve them. Okay, two linear equations. But if you have two equations with x, y, and z, three unknowns, then you can't solve them. In the sense, there is not one solution for that problem. There are any number of solutions, right? So that means that the number of variables you have and the number of ways you have of approaching those variables is not matched up. So that's what makes it an underdetermined problem. Means you can propose a large number of possible answers to the problem, but you don't know which is the correct one, or you can't tell the difference between the different answers. Okay, so this is basically what happens in all kinds of problems. All social problems, architectural problems, all problems which are really worthwhile and difficult are underdetermined problems. And so this sort of gets to this whole idea of, well, how do you approach these problems? And in architecture, you have another problem, which is that in most such underdetermined problems, it's very hard. So there are two things, right? One is you have a number of unknowns, right, in a problem, right? So, and the other thing is you have a finite set of tools, a finite set of ways of getting at a solution, right? Which is smaller than the number of. But what happens with most architecture problems is there is no general agreement about what the variables are, or how many there are, or how many unknowns there are. Like, to take like a bad example, but a useful one, I think, it is like if you say, well, let's build another airport in New Bombay, then you ask like 50 planners and they'll give you 50 different program statements. Now the program statements will mostly agree because it's an airport, but on the margins, they will disagree. And the thing is, you can never tell how significant those margins are. So in some cases, you will have very, very significant disagreements because you don't even know where the airport problem ends and other things begin. Because then, to take just one stream, you can say, well, what if we could expand Bombay Airport, or what if they have another airport in Pune? What effect does that have on Bombay, on this second airport? So if you say, okay, I want to design an airport in New Bombay, that problem is very, very hard to pin down, okay, in a satisfactory way, and nobody's going to agree. So in some literature, this is sort of a paradox of rationality, because you cannot rationally approach these problems and get to a place where they're pinned down. So in this sense, you get to this whole idea of a wicked problem, that design problems are wicked problems. And there's a whole literature on this. I'm not going to get into it. You can read up on it. The sort of the first sort of the guy who proposed this notion of a wicked problem, his name is Horst Rittel. He was at Ulm and then at Berkeley in the 70s and the 80s. but he proposed this in like the early 70s. Okay, so that sort of these sort of problems of, well, if you have a computer, because there was, while this was being proposed, there was like Herbert Simon and all who was saying that, well, really, if computers can play chess, but why can't they design a house? And this is like Rittel basically points out the distinction between these two types of problems. Because see, chess is a well-defined problem. You know all the legal possible moves in chess. You know what is, you can always tell the difference between, well, what is a legal move and what is not a legal move. There's no ambiguity, right? You also know when you won, when a chess game is over, right? And you know when it begins. So a game, for example, any sport, any game has this property that it is so properly bracketed off from the world. You can tell when it ends, you can tell it when it begins, you can tell what its boundaries are. And you can't do that with any architectural problem or any public policy question for that matter, right? So this is a basic distinction which sort of basically killed off the early enthusiasm for, well, now you have computers, now you can do calculations at a rate of speed which you would never imagine before. And so now you can solve all kinds of problems, and it's not, you can't, right? So then how? So in my sort of PhD, I looked at this, and one of the things I sort of propose is that computers appear in sort of in the study of the built environment in sort of two broad steps, or which are, in some respects parallel, in some respects not. One is, first is it appears as a metaphor, because it sort of gives rise to this whole business that design is a form of problem solving. That you have a description of the world, and you have a description of the world as you would like it to be. And then you have to find a way to get from the world as it is to the world as it should be, right? That is basically a design problem, right? So, but you can't do that. So what do computers actually allow you to do? They do allow you to perform calculations. They do allow you to produce descriptions. They do allow you to do measurements of things which you could not measure just with analog methods, right? They do allow you to test your intuition in a way that you can't otherwise do, right? So the proposition is that, so what is this? How do you describe design? How do you describe design as a way of producing knowledge or as a way of solving problems? That design is basically a practice. That's what it comes down to. Like this is what happens to actually a lot of these social, this is what happened to a lot of these social problems in around that time, in the 60s, 70s, 80s, 90s, which is that there was an early sort of positivist enthusiasm that, now we could apply rational methods and solve these problems and, get world peace, so on and so forth. And then ultimately it comes down to, well, actually the best you can do is, improve practice and make practice more complicated and so on and so forth, right? Am I losing you? Are you still here? Yeah? Okay, good. So then if design is a technologically mediated practice, right? So it is and this is this idea that, you are designing something, let's say in KRVIA or someplace, but you're going to bring KRVIA to your office or to your desk, right? You're going to make all these abstractions about KRVIA in your office, and you're going to produce a model which is specific and complete to a sufficient degree, and it is complete enough and well formed enough that you can then give it to somebody who will build it on the side, right? So that's a different model of building, and that's a different model of intervening in the built environment than sort of some older methods, like, master builders and which had which used to sort of farm out jobs to specialists, carpenters and plumbers and so on and so forth, and leave the details to them. But you don't do that. You have to make construction drawings, you have to make working drawings, and you have to go to the government and get them passed and so on and so forth. So we have this model where, we build these very, very well-developed detailed models. And I don't know if you guys do this, but, there's sort of conventionally design has like early design and then detailed development and so on and all these different stages that we learn about. And there are paradoxes in that, right? In that you make a lot of very big assumptions right at the very beginning when you know the least, right? And then as you go along, you sort of keep tweaking the details, when you start knowing a lot more. So that's sort of a slightly paradoxical process. So there are all these sort of weird things that go on when you do design. Design is a very weird thing, without question. So, but that's what makes it sort of interesting. So, I think I'll skip this because this is a experimental sketching environment on which I did a case study in my PhD, which was basically an immersive environment. So it's a hemisphere, like it's the bottom half of a hemisphere, and you have a spherical mirror on top, and you can project a spherical projection of an image on the mirror, so that when you're standing in the image, it's like you're standing in your site, like if you have a site phone. So then the proposition was, well, how does this compare to actually doing design in the site? And now, yeah, the kinds of problems to which this type of comparison available is very small. So, but as a toy problem for an experiment, it works really well. So that was sort of a set of case studies that I did, comparative case studies. I won't really go into that very much. So we come to this, and this is sort of the basic sort of lay of the land, so to speak, right? Wait, I don't know. Okay, now it's there. So I said that computing appears in parallel, first as metaphor and then as medium, as an analog which describes the process and as the machinery which which the process is carried out, right? And historically, sort of commercially, and this is academically, these things don't happen in this order, but commercially with sort of the market power of Autodesk, this is sort of how computing has inhabited architecture. Now, you guys are probably using a lot of this software, right? How many of you use like Rhino? Modo? Maya? Revit? Okay. And SketchUp? Presumably a lot. Yeah, okay. That's about the same as it is in other places. So you see, this is another thing. Like you go to architecture studios all over the world, and basically everybody using the same machine, the same equipment. And what are the implications of that? I don't know, but that is sort of a researcher's question. So the way to think about it is, and this is designed to show sort of how our capacity to describe the world increases with time in this history. So first you're describing only geometry with computer-aided design, right? You have drafting tools. You're basically AutoCAD in its original form is basically the digital analog of a drawing board, right? It's the T square and the set square and protractor and what have you. Then you start saying, well, we can describe more than just geometry. Instead of describing a cylinder, I can say that this is a cylinder which is a column and it has all these other properties, right? So I can describe objects, I can describe trusses, I can describe pipes, I can describe all kinds of things. And I can have one model of the building which everybody shares. So I can give it to my HVAC consultant, I can give it to my sanitation consultant, I can give it to my landscape architect, and we'll all share the same model and it will make life better. And it has, right? It has sort of made practice significant, measurably sort of better or measurably more integrated is not a good word, but for now it will do. Now, what are the models, right? And this is where it gets a little bit interesting. Now, in things like physical features, right? You can do climate, physical things like temperature, humidity, daylight. There are models from physics, acoustics, There are models from physics and models in engineering which you can borrow, and you have your object model for building build spaces, and you have, the way sound propagates. You can say, okay, it's the inverse of the square of the distance or something like that. That's how sound behaves. Or it's the log or something. And you can say, well, what is the loudest? What is the decibel level of this building, this room right now? And the decibel level of this building the room right now is basically the maximum noise that one source in the building in the room is making, because that's how you calculate a decibel. So, but these models are not developed by us. These models are developed by physicists or engineers, and we just borrow them, we combine them, and they have been much more mature. They've been around for 25, 30 years now. They've become, commonplace in practice also. I mean, there are jurisdictions in the world where there's a requirement that you perform certain types of energy analysis and climate analysis and daylighting analysis and submit it along with your documents when you apply for approval, right? So these things are sort of come into practice. Where we have not made as much of an advance is in describing use, and this gets to the sort of the basic question which all of you have encountered, which is that, do you show people in your section? Do you show people in your elevation? Do you show people in your views? Do you even show people in your walkthroughs? And if you show people in your walkthroughs, what are the people doing? Do you know what they're doing? Do you have any idea, any model of these people? And we don't, because unlike say with thermal conductivity, how or sound. We don't have these models. We don't have models of like, okay, how am I going to behave in this room right now? How are you going to behave in this room right now? We can sort of say ad hoc, if I see you, I can describe that you're sitting here, you're listening to me, etc., etc. I am assuming that you're following what I'm saying, so on and so forth. But there isn't like an underlying model that we agree on. Like there isn't an equation or model which says, okay, this is how I predict you will behave, but this is how I predict I will be. Those models do not exist. Okay? And so that's why our advances in this area, in describing social problems, in describing social situations, is not as advanced. So this literature starts like in the 70s even, and it really takes off in the 80s and 90s. There's a lot of works and stuff. This stuff, to some extent, it starts in the 80s in very narrow circumstances, which I'll describe, but it starts much more in the 2010s. Okay, and it's still not mature. Like compared to where this was in the 80s, this is not even there even now. So we are behind in describing models of people. So much so that, when the BIM standard was made, the ISO standard for BIM, on which all these Revit and all these softwares are based, they made a conscious decision not to include a person as an object in their BIM model. BIM model specific, and they have all sorts of things. They have slabs, beams, trusses, staircases, windows. They have composable objects and elementary objects and what have you. They have all manners of describing spaces and concrete and steel and wood and what have you. But they don't have any way of describing people. They've left it out. And there's a whole sort of literature on why that is. And mostly it has to do with this problem, which is that, well, we don't really know how to do it. So we don't do it. And it seems to me that this is like a really bad problem for architects to have. We design buildings which are going to sit there for 50 years, in which people are going to do all sorts of things. And we don't have the first inkling about what people are going to do. And this gets to sort of the core thing which always bothers me about architecture, which is that we say things about our designs. We say this will do this. And the question is, how do you know? How do you know it will do what you say it does? And you don't really know. But in the profession, there is a convention that there are certain things which we accept will happen. And even though they don't always happen, our systems of updating those beliefs are necessarily ad hoc. So now there is some sort of exceptions to this. Like there are ways where people have been modeled in narrow circumstances. And the two sort of classic examples of that is evacuation situations, right? So if you're in a movie hall and there's a fire, then you have to have a way to evacuate, I don't know, 300 people in a matter of minutes. So how will the people behave, right? So the model of a person as an evacuee in the limited circumstances of evacuation that people have tried to develop, but that's also not trivial, as I'll show you in the next slide. The other is this question of, as consumers of electricity. So in the energy literature, in the literature on climate control of buildings and all, there's this whole idea called comfort. The people are trying to measure how comfortable is the occupant. And this whole notion goes with one of the areas in which this works is, well, what is control got to do with comfort? Like, for example, if you live in this large open plan office, right? And suppose there was one switch which switched on all the fans and one switch which switched on all the lights, and that was it, right? As opposed to, let's say, another situation where every desk has its own little fan and its own little light, right? And all of you get to switch it on as you want, switch it off as you want. You are the king of that place, right? So in what circumstance would you be more comfortable? And not only that, but in which circumstance would you end up consuming more electricity, right? So what is the relationship between having a centralized system as opposed to a devolved system and consumption? And that's a question of behavior, because that is predicated on how people will behave, right? So in that particular circumstance, a person as a entity which operates a light switch or operates a fan switch is an occupant, and to that extent, occupants have been modeled. But people are well rounded. Right? People are now. The other thing that happens here is that the model which is used to describe occupants and the model which is used to describe evacuees, there is no common underlying model to that. And in BIM, this is true. Like, for example, if you are designing a school, okay, and you're designing all whatever rooms and courtyards and whatever you have, right? And if you're designing a hospital and you use the same underlying BIM model to describe both. There is no comparable underlying BIM model to describe the evacuee and the, I don't know what happened. To describe the evacuee and the occupant. And these are two sort of, they might as well be like, apples and oranges. We have no way of describing a fruit and saying, okay, this is an apple, which is a kind of fruit. This is an evacuee, which is a kind of fruit, right? So we've been trying to build that. And, I mean, this is just this is just a slide which shows like to what extent this work has sort of extended. And I told you about the problem with evacuations and describing evacuees as emergency situation. Now, it turns out that if you're in that situation, one way to say is that, okay, every individual will get up and make for the nearest exit. This is the advice you're given, right? Everybody, you've been through this situation. You've been to in a plane. If you've been in a plane, this is what they say. Find nearest exit, go to the nearest exit. But people don't behave like that. You go to a movie with some people, with your friends, or with your family. And the first thing you do if there's an evacuation scene is that you look for your family. You look out for your family. You are not getting up and leaving for the exit. So that is spatial behavior. That is going to affect other people's behavior. That is going to affect the efficiency of the evacuation. You can imagine a world in which everybody is just an individual and they are leaving. And you can imagine a real world where you have this problem, right? So a recent model proposed that people behave at least 3 levels. One, first, they behave as individuals. Second, they behave as part of the group that they are with. And the third is they behave as a collective. And every decision involves at least these 3 levels of behavior. So now already you see sort of how complicated this problem becomes, even this small problem of evacuation. Of trying to simulate, trying to describe how evacuation would work and how I would need to describe a building to, or how I would need to design a movie hall to make sure that people can evacuate comfortably or people can evacuate at all, right? Now, we have time saver standards which tells us how you design a movie hall, right? Do you still use that? Yes? Time saver standard, they're not used. Okay, it's there, it's good. Okay, so time saver standards tells us like what the dimensions of a movie hall should be, what the design should be, how many hallways, how many sort of corridors there should be for each seat, and so on and so forth. But what is that based on? Right? That's not based on this simulation. So that's based on some analysis, but it's not based on sort of any evaluation of behavior, right? So this is a big problem. This is a big research area, which is sort of going to hopefully advance in the next 15, 20 years. So we've been, in my postdoc, we work with this hospital in Haifa, where half the doctors are Arabs and half the doctors are Jewish, and Haifa is this mixed city, and it's a complicated situation, and it's actually a quite wonderful situation in the north, not near the borders, but in sort of the heart of the north of Israel. So their problem was that they built these new hospital wards, and nowadays with hospital wards, the big expenses machinery. They buy this very expensive equipment, and this equipment also advances every 4-5 years. And with advances comes the spatial implications of successive generations of the same machine are significant, right? Because machines are miniaturized, machines occupy less space, they occupy less electricity, sometimes they require fewer staff to use them, and so on. Now, the build cycle of a hospital ward is 5 or 6 years. So from the time you say, okay, I want to build this ward in this floor of this building, to the time you actually have it ready, it takes about 5 years. Now, 5 years, the assumptions you made at the beginning about machinery may be obsolete, right? So your design is basically not useful, even though it will be there, right? So, and you could do real-time mock-ups, right? You could, but those are really expensive. So they wanted sort of a way to evaluate this problem. This is a hard problem for the reasons I described before, that there's no model. So we had to build a model. And so in environmental psychology, there's this notion of place. And I think you should encounter this idea at some point. And if you don't, then you should look up Edward Casey's history of place, or history of the concept of place. It's a wonderful book. You should also read Himanshu Bhutte's work on place. Himanshu is a professor at IIT Bombay. Now, so a place, we say, let's say, is made up of people, space, and activity. These are the 3 things which you take them together and you get a place. You need at least these 3 things to constitute a place, right? Okay, so I'll give you an overview of this. So essentially, what you need is, as I said, people are behaving as individuals, groups, and collectives, right? So you need a way in which you have agent-based models, and you might have come across these if you play video games, where you have non-player characters, which are basically, automated agents. And you need a system to sort of manage the agents. You need a system which governs the agents. And there's a lot of sort of details about, where you locate the control, how much control you locate at the agent, how much control you locate at the event, and so on. And how you have sort of control devolving down the tree and going back up the tree and so on. Those sort of complicated details about, finite state machines and behavior trees and so on, which, you won't go into the boring graph theory stuff. But, so we devised this model, and one of the things we realized is the same thing that I told you before, which is that we could describe an orthopedic ward where, people have basically broken limbs or those kind of problems that they go in for operations. It's an inpatient ward. And then we go to, let's say, a maternity ward, which is a completely different proposition. And we found that the model that we devised for describing the orthopedic ward gave us nothing, no insights into describing the orthopedic ward. We had to start again in the new ward. So you can imagine how annoying this is. Right? You solve a problem and you're not really solving anything. The next time you're still starting from scratch. Right? So, but still, our system did sort of work, and we found that, we were dealing with doctors and medical administrators. These are all very high-five people, they're like MBAs and MDs and stuff like that, and they're managing $100 million budgets and things like that. And we thought that they would want metrics and things like that, right? So we had sort of these groups of different types of actors, and the hospital is actually a relatively simple problem from this point of view, because there's a very clear hierarchy in the hospital. There are patients, there are visitors, there are nurses, there are doctors. It's not a public place in that sense. So it's the whole normal controversy about, who has control and the politics of control is sort of fairly settled and structured in a hospital. This is also why a lot of social studies and spatial studies actually happen in prisons, for the same sort of weird reason. So we are able to show this. So we could devise metrics. For instance, one of the metrics we found is that if you have this nurses station, and in an alternative, we have sort of turned this around and have the nurses station in one end, then if certain machinery and certain processes remain the same, the nurses walk 1.2 kilometers less per shift. Okay, a shift is 12 hours over there, and you do a 12-hour shift every 4 times a week. Okay, that's how here we have this interesting thing where, it's trade unions are very strong over there. So the nurses union is very strong in these negotiations. So they are at the table. So we came up with all these metrics, but when we found out that if they use this new system of disseminating medicine, I'm going to give, there are 2 different ways of disseminating medicine. Then if you move this over there, then it actually increases the nurses' average walking during a shift by 300 meters. Okay, so now we thought that they would want to see all these metrics. So we produced a report and we put all these metrics in there, and we gave it to them. And then in the meeting, we found, perhaps we shouldn't have been surprised about this as architects, but we found that what they really wanted to do was to watch these videos and get a sense of, what the behavior in the hospital was like, and so on, right? But okay, there's a bunch of sort of detail about Okay, good. So there's a bunch of detail about this, how you describe spaces and how you sort of manage hierarchical spaces. And this sort of uses actually Sabu Francis's a version of Sabu Francis's atoms, envelopes, connectors system. You guys should read about it if you can. I mean, I'm sure you will find it on the internet somewhere. But basically, we wrote a hierarchical search. This is again boring graph theory. And we are able to basically describe how agents will behave. I hope this works. Yeah. So each agent at every step is evaluating the world as it is and taking a decision. And there's a place that the agent needs to get to, right? So this is sort of a prototype of how an agent acts spatially and socially, and a system where you can describe all kinds of complicated system. And so this is a system that we developed, but it's still the beginning. Now, just do this. Now, if we have so what would a BIM for use look like, right? So a BIM for buildings is what? Slabs, columns, beams, etc., etc. That thing you see in the menu on the left front Revit is basically what would a BIM for use look like? And a BIM for use we suggest is this syntax model. It has a hierarchical spatial description, which we use basic sort of cellular automaton based system, but you don't have to. I mean, there are other ways of describing this. And it will have a description of an actor which accounts for space, which is a spatialized description of an actor. So an actor is only there if the actor can be located in a space, right? And then there are actions. What do they do? And this is like the really sort of, I think, interesting part of this, which is that what is a decontextualized description of what people do, And what this does is, if you sort of think about this backwards, then people do all sorts of things and people are motivated in all sorts of ways to do all sorts of things. But the point is that whatever they do, then if I'm standing here at time t, okay, where will I be at time t plus 1? There are only a certain number of possibilities there, right? So whatever you have is you have to have a way of evaluating these questions of what are the events that they are, what is their purpose, and being able to translate that into where the actor will move there in the next step, or the actor will stay here, right? So either I go somewhere else or I don't, okay? And either some other feature of mine gets updated, like I get more tired, or and so on and so forth. So you can have a finite model because ultimately you're concerned with 4 dimensions, the 3 spatial dimensions and 1 temporal dimension. And whatever happens, it has to finally be manifested in those 4 dimensions, right? So in that sense, it is possible to have a context agnostic, a model of use the way you have a model of buildings and BIM, right? So we sort of devised the building blocks of this type of model. And this requires some more work, but this is where it is right now. Now, I want to put it to you. I want to bring this back to something you may have seen before. How many of you are familiar with this? Not the professor. Yeah. So this is a Noli map. Giambattista Noli was an 18th century cartographer, actually also polymath in Italy. And he built basically a floor plan of Rome, where he describes built spaces and public civic spaces in Rome. And he uses this figure ground method. So what that does is that it gives you sort of a map of publicly accessible Rome. Right? Now, think back to the way we are able to describe the hospital ward and behavior in the hospital ward. Now, the goal of this, as far as I'm concerned, what I want to achieve is to sort of bring this to life, essentially. To be able to, we can do this now. This is trivial in 2023. This was actually trivial even in 1963, right? We can do a very accurate floor plan of Bombay, so to speak. If you cut Bombay at, I don't know, 1 meter above the ground, then we can sort of build a bigger.
Again.
Sorry.
Again.
So anyway, this guy Noli, he built this whole map, and there's a digital version of this map also. I'll have the link in the next slide. It's done by actually it's done mostly by Steve Tice at University of Oregon. But I think it is now hosted at Stanford because they have a history, a spatial history group there. So the question is, what can you describe, and what use is it to have these types of descriptions? So, for example, right now, I'll give you an example of a problem that we're taking, which is that suppose you have a situation where the city is thinking of modifying a bus route. Okay, and that bus route is used by school kids at times of the day, right? And if you can show, for example, what the consequences of taking that bus route will be. The kids who are taking that bus to school are going to have to, walk, or going to have the commute is going to increase from 25 minutes to 45 minutes. If you can actually show that, it is one thing to say that. It is another thing to show that. And being able to show something, being able to show that something is true is persuasive. It is how decisions get made, whatever people say. It is the world works on evidence. The world works on what you can show, not what you assert. And regardless of what they say on Twitter, this is true. Okay. So the idea is that if we have a model of use, if we can describe how people behave in spaces in a syntax, we can have a syntax for that. And then we can sort of use that to describe markets and jobs and whatnot. Then you have increased the capacity of the profession. You have increased the capacity of the discipline to, or maybe even not just increase, but also complicated the capacity of the discipline to revise problems. Because all this comes to this basic question, which is sort of what bothers me quite a lot, which is that what is an architectural problem? We are able to think of problems of the city as problems of urban economics, or problems of law, or problems of sociology, or problems of anthropology. So where does an architectural problem begin and where does it end? And we have no real good definition for this. This is why when you have to do research in architecture, you very quickly start having to learn other disciplines, like computer programming, computer science, learning how to talk to a computer, basically, learning what will be and all that. So that's another boring side of this thing, which I am not going into at all in this. But that's sort of the nuts and bolts that you learn. That's the capacity that we build. And I think part of the reason why our capacity to describe architectural problems is so limited is that our means of describing the problems are limited. And we say that we do people-centered stuff and we design buildings for people, and we have no means of describing people in our models, or people's behavior in our models. We have made no assertions about that. We have basically abdicated. We have said we are not going to try, and this has been true for a long time. So the presence of people in sort of, and actually we've had sort of in the 20th century, in sort of the modernist history and the history of form, we've had this situation where there are architects who actually insist on not having people in their monographs, in their science. There's a famous story of Peter Eisenman selling, going to a house which he designed, which was inhabited by a family, had a small child. And, very responsible from they had like their toys and their pram and all that strewn about. And Eisenman's photographer went into the house and he's going to photograph this room. And Eisenman tells the family, get about this. What is all this? Why is this here? As if this is sort of an astonishing inversion, of the purpose of architecture. And there's sort of an ocular-centric aspect to this, where there's sort of very, very predominant, we are obsessed with what things look like rather than how things behave and what the consequences of things are. And so I think I'm sort of so the point of sort of doing research is to look into these types of questions, which are, not sort of, for which you have to go somewhere to look. And the other side of research is to sort of try to devise an answerable question. So I think this is an answerable question, but it's a difficult question. So it sort of has enough richness to sort of, require significant effort for several years, and to build sort of a, because ultimately it's not just a question of building a model, it's a question of persuading other people that the model works, and get people to use it. Because that is how you sort of advance things, right? Because you start getting people to use things. So yeah, this is the idea. If you've been preoccupied about your thesis while I've been talking, I'm entirely understood. Thank you. Okay.
Thank you, Dr. Ravli, for this insightful lecture. Handing over the mic to the discussant, Mr. Ravli.
So while she's giving the mic, this is the site. It's Stanford University. If you search for spatial history group, Noli maps, you will come to this interactive Noli map site. It doesn't have people.
Thank you so much for this amazing presentation. I think it's sort of, let us all sort of just step back and see what kind of information we're able to perceive as architects about space today. And I think it also brings up an interesting conundrum of how we sort of discuss. It also sort of highlights an interesting conundrum of how we discuss drawings with each other versus the presentation where you have like a drawing when you discuss the architects, when you have a presentation where you're talking to clients or something like that. So with so much information, there's sort of a different way you read information as architects versus when you try to present a layman. So with information sort of outpacing the way we sort of design, and with so much more information coming in, I mean, it sort of begs the question, do you think we're going to eventually reach a consensus where the way we speak layman and architects is going to be the same because with so much information, we're going to have to develop a common language? Or are we going to start diverging into these drastically different paths where with so much more information, as you can see in these simulations and so much data about human activities, what is relevant to the client, what is relevant to architects, what do you want to show other architects, students, and other practicing architects, what do you specifically want to show your client, because they will care about a certain particular item. Are we going to sort of see an elaborate sort of thing where again, a sort of consensus on this, or do you think we're going to sort of evolve different languages of talking to each other to a point where, because we've never seen such information coming to architectural landscapes. What do you think is going to go towards?
Well, actually, this is you can hear me? Okay, good. Well, the honest answer is I don't know what's going to happen. I mean, just to give you an example, just the basic practice of going on a rickshaw ride has completely changed thanks to Ola and these people right now. You don't need to know anything. You don't need to look out. You don't need to ask people. We still do, but we don't need to. The honest answer is I don't know. I don't think it's possible to know. to make these kinds of predictions. But I think sort of I don't think it's a good idea to sort of say that nobody sets out to change the world, in this. You set out to solve a problem. And the difficulty with that sort of thing is that your solutions have consequences which you do not intend, right? So, but there's nothing you can do about it. I mean, that this is a sort of a thing which happens a lot in architecture, especially, because it actually happened a lot in design methods. For instance, the history that I talked about in the beginning, which is that when the whole sort of problem of making design systematic, when the sort of the efforts to systematize design, to make it a rigorous sort of predictable, measurable process, when those broke down, then what remained was basically criticism. And criticism has its place, but it also has its limits. You have to intervene ultimately in the world, right? And it's no good to say that, well, you shouldn't intervene at all. You are going to have to intervene, and that intervention is going to have consequences. So I think your sort of best bet is to at least be able to convince yourself that your intervention is in good faith, so to speak. That's a very general thing, but in general, if there's an obvious sort of difficulty, then be alive to it. And the whole point of sort of building up the profession, building up the capacity of the profession and the discipline to represent problems is to equip architects and urban planners and people who study the built environment to study it better. Now, I do not. So there is a sort of what should I say? There's a positivist approach to this, and there's a sort of what do you call it? It's not an anti-positivist approach, but there's a sort of there's a pessimistic approach to this, and I don't think either is tenable. I think life has to go on. You have to. There are problems, and you cannot ignore them. You cannot say that we're not going to do anything because we can everything we propose to do. We are going to sort of find some problem with it, which is the critic's job, and critics do an important job. But architects are not critics. Architecture, urban planning, these are not sort of fields of criticism. They are fields of intervention. So, what is the effect of big data? Honestly, I don't know, but then we do have another problem which I've been interested in. I talked about architectural representation. And for the most part, when we talk about architectural representation, we talk about drawings, models, 3D, right? Plans, sections, elevations, etc., etc. Now, for the most of the 20th century, it was really hard and really laborious to produce photographs. Right? You had to have film, you had to get that film developed. You could only do 36 at a time. If you're lucky, you could do 72, so on and so forth. So one of the consequences of that, and this is true for both statistics and history, is that the methods of statistics and history were both developed and advanced to operate in data scarce environments. Statistical sampling and all these things emerged because data collection was expensive and difficult, laborious, and often prohibitively so. So you had to have methods by which you could sample the population and draw reasonable conclusions about it. So, but now you have this opposite problem where you have a glut. So for instance, one of the problems we deal with is that now you have, if you're doing urban history in 2025, let's say, or 2050, let's say, of Bombay in 2020s. If you did that in 1950, about the 1920s, you would go to the government archive, you would look at canonical examples, you would go to some private archive, and that would be your sense, right? But in 2050, you know that in the 2020s, Google offers like this exhaustive street view of every street in the city. and it updates it every few months. Now, how do you write a history of Bombay while ignoring such a huge data set? And that's excluding like some people are putting on Instagram and what have you, Flickr if it's still around, or whatever, right? So now you go from a place where image production is really expensive and difficult and laborious to a place where image production, storage, and retrieval is trivial, right? So the representation of the city that you have available to you has changed fundamentally. So to what extent can you use images as representations? That's an open question again. And all these sort of image classification models and segmentation models and what have you are, I mean, they change the way you make categories in history, the way you choose case studies, the kinds of case studies, the kinds of multi-case studies you can do, all that changes. So do I know how that history is going to be written? No, I don't. I mean, I don't think anybody does, but that's sort of an open question. And as far as the language is concerned, I think professions develop because of this problem of language, because you need specialization, because you need jargon, because you need shorthand, because you need people to do work which you can't do yourself. Because you need people to study things which you can't study yourself. So if I were to make a prediction, I think it won't happen. I mean, there won't be a common language. In fact, there will be more specialization. That seems to me to be the more plausible possibility than the other possibility of sort of, the layman and the specialist merging to speak the same language. Now, as a democratic proposition, I'm not sure what that says, but that's what I think is going to happen.
Thanks so much. Now I'm going to hand the phone to the faculty. Ramesh, would you like to take over?
I'll just my question, or rather, it's an answer to what he asked. I feel there's always ways to represent. There'll always be techniques, and the only answer or the only right way is adapting towards it. There is no division, and there is always an overlap in decades. There will always be people with 10 years gap who not want to adapt. The only option is going towards. And we've already seen that. We see people, we also closely work with people who have, speaking more on fabrication terms, who have been always working hands-on. Even as students, we started drafting first, using drawing as a medium. All the software, all the representation that we see today, even in terms of algorithm, is just the medium. The tool was important, it was always trying, and unless the control is always in the hands of architects and designers. The design part will always be in our control. So that is a never-ending sort of discussion. But yeah, unless the whole code is in our control, it's always going to be. Yeah. Thank you.
I think there's a hand behind you.
Shantanu.
Hi. Yeah, so I think interesting discussion we generated here. I think two part, maybe one's a comment, one's a question. And to start with, I think I'm sure you are maybe a student of this book, Bill Gilliard, William Hansen,
Syntax.
Space Syntax. So I mean, I was a student when this research was going on in London, and I was a student of this work. And but I think in the measured word, what we see is that the measured word is still tending towards controlling humans socially. And I think that's the destruction of the social milieu. And that's what modernism did, and that's what we are controlled by. And even in your study, I did feel there is a kind of policing of the nurse. putting her on a kind of a tight assembly line, which is, she would have rather walked that 1.2 kilometers more if she got to meet a friend in the back alleys and discussed her marital problems or her problems that children are facing, which would give her a better, perspective on life than being controlled by whether it's the Jews or the Arabs, I don't know, but one of them. So given both, yeah, of course, I'm just being a little critical about that scenario also. But given that the tools are always being used to constantly emphasize surveillance, where we become machines and we lose perspectives as people. So I think that's one comment that I'm trying to make. And of course, I think in this book, Space of the Machine, they try to look at the social aspects of how do you compute and do see people coming together as social people, etc. I think that is one thing that is not being pushed. People are not taking that agenda forward, is my fear. It's wrong. And I think in terms of problem solving, this is the second part, and I think very interesting. And when we practice how we address it, I think I would come to as an example in a school that we designed for an architecture school in Vijayawada. It's a unique problem that, when we design the staircases of the building, it's defined by the, what we call the CFO, Chief Fire Officer. But when we actually design the elevator, it is defined by something we call the 5-minute handling time. I don't know if schools have heard of it, but that's what controls it. One is controlled by, building codes that are mandatory. The other is controlled by something that client can decide whether I want 5 elevators or I want 6 elevators. It's more like a luxury. You can decide how many elevators you want, and the budget sometimes decided. So if you look at elevators versus staircases, both are doing the same job actually. Yeah. But if you decided that if you didn't have a luxury of many elevators, if you decide to hide your elevators and make legible your staircases, there's a very high chance that nobody will use the elevators. Yeah. I'm sure they use it if you go for foot. So what we're trying to say in effect is you start simulating a condition where, because of legibility of the movement in the staircases, you will find a larger use of staircases. I think these are the kind of studies that this is practice actually. It's got nothing to do, it's a condition that you develop only because of practice. Vis-a-vis, if you went into a John Portland atrium in a hotel, the elevator will be the kind of an iconic element that travels exposed in the atrium, which would look like, wow, this elevator travels and everybody sees it. But if you immerse that idea, people start using the staircase. Of course, how interesting you make the staircase. Does it become a boring dabba like a scale, or does it become a meandering stair that you meet your friends along the way? So that is a design element again. So I think that the idea is, how do you use data? I think that becomes important. If you add social layers onto it, if you add more and more layers onto it, I think you can take it to the next level. But depends on who uses data. I think that's the thing. If it is somebody who wants to control you, or if it's somebody who wants to liberate you. I think that's where the problem of architecture really lies, is that we have erased the social milieu in our lives. And modernism, of course, did it very well. Finished our social life. We don't have one. We only talk about environmental sustainability, social sustainability now. We all have mental problems, right? Too much stress. And I think this is the problem with data. The data problem is it needs to be equitably used. And the use of data is important. Who uses it, and what perspective you come with, what perspective I come with. This becomes the biggest ethical question today we have, I think, in the globe. It's a big global, I think, pandemic, I would say. Yeah. I don't know what's your view on that.
Should I respond now?
Yeah.
No, I take all your points. I mean, should you actually describe how people behave in buildings? It's an open question. There is not at all a foregone conclusion. It's a good idea to do it. I think in certain circumstances, it will be useful to be able to do it, which is sort of why we're doing it. I mean, how do we be free as social animals is not a question to which I have an answer right now, but I appreciate that it is a very good question. Because there's a paradox, right? I know all interesting things in life are paradoxes, I think. But what I would say is that, look, someone is going to use the data. Someone is going to create this data. If you don't do it, somebody else will do it. And the question for the discipline, the question for the profession, I think, is what is our future if we don't do it? What is already, there's already, 10 years ago, 15 years ago, there was already a crisis in architects who had a similar attitude to BIM, because it was sort of empowering specialist consultants and contractors, because we are now sharing our model with them. And it would give rise to sort of specialized sub-disciplines and sub-professions, where you had now new practices which were doing only those things, and those were very lucrative. So, yeah, there's churn in the profession because of when its instruments change, the profession has to follow or die, I think. And there are examples of professions which have died because instruments changed, and professions were no longer required. So the architecture's fate is probably not that dramatic. This is, it's probably not a good idea to paint it in colors that are as primary as I have. But nevertheless, I think with this sort of, there is modernization in India. Today, and there is not only modernization and modern, there's differential modernization in India, in our cities. And so the question is, I completely take the point, this is a point which gets raised quite a bit, which is that, if you parameterize, if you build models, then whoever is able to run that model feels a lot of control and a lot of power. So the question is, should you have such models? But you cannot wish them away. You cannot wish away the fact that you are going to have a digital footprint. The question is, do you make peace with it? Do you find a way to be at ease with it? And for that, you have to use it on your terms. And you have to use it for yourself. You have to use it for your problems. So you have to use it to counter parameterize, what someone else is doing. Because as I said, it's not really a question of, the nurse might want to, have her freedom and not be monitored and the nurse is not monitored. But the thing is, the nurses union, which the nurse voted for, is very, very upset that the nurse has to walk 1.2 kilometers extra per shift. Because that has real consequences, versus they get long-term injuries, they get long-term, damage to their health because of that. So this is why sort of I'm not really, I appreciate the work of criticism, and I think it's essential, it's necessary. I think it should always occur. But I think at the end of the day, I think architects have to intervene. That you have to make a decision. That's why you're the architect. You have to decide. And what's more, whatever hospital you design, you have decided whether you use the instrument or not. Right? So whether you have made a hospital where the nurse has to back 1.2 kilometers more, or whether you have made a hospital where some other situation occurs, you have done that. You are responsible, right? So I don't think there's a way out of that. Right? So this is why I think that these problems of representation are sort of basically architectural basic problems. Because the idea is not to describe buildings, no? The idea is to describe problems. I don't really care about, a building, what a building looks like, because I'm not going to be there most of the time. But when I go there and when I have to work in that building, or when I have to make use of that building, when I go to a building where most of the visitors are strangers, and if you hide the elevator, that's one thing. But if you go to a building where most of the users are regular users and you hide the elevator, then elevator use will be different, right? Because the people using it are different. There are most of the people walking into the building know the building inside out. Okay, maybe not the first time they walk in, but the 10th time they walk in, they will know. Right? And this is sort of the whole point of, being able to think these things through systematically. And to do that, you need instruments. You need to measure. You need to evaluate. And we do that in all these other things. So we should be able to do it in this also. This is what I think.
So much for joining us.
So you guys don't have to say anything about it. Yeah, I think it's time for
So we
lunch.
can continue the conversation downstairs and start if you're interested, but we'll end the session for now. Thank you very much.
Thank you.
Stop the meeting. Exactly.
Was okay? Was it like lost?